Good morning, everyone. My name is Wirarama. Today, I would like to present our paper with title Solar Powered IoT-based Smart Hydroponic Nutrition Management System using FIRM. So, background of our research is a nutrient in hydroponic system are periodically remixed to target the right amount of total dissolved solids. The TDS amount needs to be periodically measured after the weather change, namely temperature, humidity, light intensity, and rainfall. Okay, so our proposed solution is a solar power Internet of Things based smart hydroponic nutrition management system using fuzzy association rule mining. The system consists of IoT connect to a TDS sensor, a relay module connected to two 5-volt mini pumps that supply AB mix nutrition and a solenoid valve to supply water. So that's the main part of the system, and also the other part of the system is this system is also connect to the sensor for temperature and humidity, like intensity and rainfall to record the cause of weather change that cause a change in TDS. Okay, FIRM is used to extract fuzzy association rule, or we short it as FAR, from IoT sensor in precedent and dependent format. So we not just controlling the nutrient supply, but also extract the rule in precedent and dependent, which precedent is a cause of the TDS change and dependent is the TDS itself and how we control it. So it's a related research. So there is already a lot of automations research using IoT to control the nutrition. Okay, and also already a lot of algorithm that try to make a efficient controlling and predictions, or expert system that make its own rule. So novelty of our proposed research is using association rule mining, not an expert system that we make a rule, but we make an algorithm to extract a rule. The proposed research also consider the effect of environmental variable, including light intensity, ambient temperature, and humidity, and rain intensity to change the TDS and nutrition system. So all controlled by rule, but rule that's extracted by the algorithm, not a rule that we make by ourselves, by literature. Okay. The proposed system extract rule based on environmental conditions using FIRM fuzzy rule extraction to adjust the nutrition supply. So we aim not just controlling the system, but also describing the environmental situation. So, and another novelty of our research is the system is solar powered and low power computation, not using a high power server, but only using a Raspberry Pi and another microcontroller. Okay, so this is a general view of the system. So sensors are connected to the microcontroller, and we using a 2 solar power and 1 AC power using a 12-volt power supply to supply the solenoid valve energy. So this system is not totally solar power, but still using regular power just for a solenoid valve. Okay, so that's the system. Okay, so this is the flowchart of the system. So we start the preparation using IoT system, hydroponic and FIRM that's stored in Raspberry Pi. So we start with precedent data collection. First is ambient temperature and humidity, light intensity. That's cause of the TDS change, and dependent data collection, which is TDS itself. So we check if TDS are changed, depend on threshold. So if not changed, it's also stored as unaffected rule. If affected, so we store affected rule, and if the TDS is increased, we supply water, and if decrease, we supply AB mix. So after all rule are stored, we using a FIRM rule extractions and store it rule pool, and we do the evaluation until support and confidence are satisfied. Okay, so this is the IoT circuit. So we use two kind of solar power charging module to the battery TP4056. So and we use two microcontroller which connect using a software serial Arduino Nano and Wemos D1 Mini. So we use Arduino Nano because we use a lot of analog sensor, and Wemos D1 is used to upload the data to the internet and connect with the Raspberry Pi. So only thing that controlled by the Wemos is just a relay module that also control two water pump that using solar power and solenoid valve that using a AC 12 volt adapter. Okay, so this is actual FUDO system. So this is the main board of the system, which is only 5 and 7 centimeter that we connect using a wire wrapping technique that doesn't give a lot of heat to the cable using a pin header. So we also can simulate the multi-layer connections in the PCB using this. And we can make the system in a small size. Okay. So this is the result. So our TDS target is 1,200 milligram per liter, and in this table we show the best result is in 50 threshold, and also the higher threshold extract more rule, which are 12 that we use in the IRM processing, and standard deviation is not much different with 30, and it's better than most strict threshold, which is a 10. And 10 just extract two rules because if a threshold is too strict, we can use make the we can see the environment change that affect TDS. So if threshold is too strict, we can control the water supply with solenoid valve. That's our mistake, using a solenoid valve, not a water pump. So it's getting worse in lower threshold. Okay, so this is extracted row. We separate into two clusters, TDS decrement and TDS increment. First, TDS decrement show condition of decrease in TDS, namely high current intensity. So there's 3 days that mostly rains that in this research. So ambient humidity is also high, and low light intensity because there's a cloud, and ambient temperature is also lower. So line water, humid air, and low evaporations may be the cause of reduced TDS, but also maybe this condition is also affected by the water supply that overload in the solenoid valve. Okay. Next, incremental, so nearly zero rain intensity and ambient humidity, and high light intensity and ambient temperature that cause this model. So nearly zero rain. These conditions increase evaporation of water, cause cloudiness of the water. So AB mix we supply with power plant easier to calibrate because we use a charging module that make a consist of 5 volt voltage, so water pump itself can supply the consist water. So in future research, we use a water flow sensor for the water supply, or also using a water pump to more calibrate the water. Okay, so this is extracted rule in the conditions of precedent and dependence. So rule 1 to 4 is describe the major TDS decrements, which in support we measure how these conditions of precedent occurs in the total instance, and confidence is how these two conditions occur in total precedent conditions. So confidence is most higher in write intensity. So in this research, write intensity is most factor that affect both TDS change, both in 6 to rule 6 to 9. Also, it's more confidence in rain. Sorry, I forgot to describe. R is rain, L is light intensity, T is temperature, and H is humidity, and TDS is TDS. Okay, so TDS 1 is decrement and 2 is increment. So 1 to 4 is decrement, and 6 to 9 is increments with measure, with it's a linear, that's more combination situation. Okay, so this 3-part is higher than just a 2-part. So it means the high in lower intensity is also trigger the lower temperature. Lower temperature in this scope, okay, of data. Okay, also humidity. Okay, so it's decreased. It means lower temperatures not always followed by low humidity. So another we also can extract the rarely occurs conditions such as sunny condition with rain, or another there's no rain but low light intensity and more. So conclusions of the system is prototype of PCB developed in small 7 centimeter single layer PCB using a wire wrapping technique, which we can produce it as cheap and very small. So we have a standard deviation 2.345 for TDS and 1166.17 of milligram per liter of TDS, and threshold 50. In 1 week of evaluation, there's 3 times of rain and 4 times of hot weather that were considered to change of TDS, and 7 actions to the relay been carried out. Has exact rule with average support of 0.401 and confidence 0.806 to 26. Okay. Future watch addition of more sensors such as pH, water temperature, more detailed calibration of water supply to decrease the TDS. Development of IoT system also needs to be improved so that more distance to water and humid temperature. And that's all. Thank you very much. Arigatou gozaimashita.